All right. People will watch this for centuries and look upon this class as a pioneer in math education. Yeah. All right. So we decide 2x times 2x got me 4x squared. Do we agree with that reasoning? Have we had a chance to think it over, come up with second thoughts, Rose? Am I right? Yeah. Are you just saying that because I'm the teacher? No. Josh is being more honest, right? All right. So 2x times 2x is 4x squared, right? So let's test that. Let's take 2x times this whole thing. So 2x times 2x, 4x squared. Good. 4x squared. 2x times negative 3. Josh, 2x times negative 3. 2x times negative 3. Negative 6x. Good. Negative 6x. And I am subtracting that whole thing, right? I put the parentheses around it because I have to do what with the negative? Yes, boom, boom. But tell me exactly what I am doing. I am distributing the negative. I am using the distributive property to distribute this negative sign throughout the term that's in the parentheses. So, and how do I distribute the negative? Boom, 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 right? Boom, boom, boom. Now I got 4x squared minus 4x squared, which gets me 0. Thank you, Taylor. And then I got negative 16x plus 6x, which gives me what, Caleb? Negative 10x. So I got 0 minus 10x. Yes? Yeah. Yes? Yeah. All right. Now, what do I need to do now? Tyler McAlpine, what do I need to do now? Pull a 15 down, plus or minus 15? Plus. Tyler is paying attention. Thank you, Tyler. Now, how many times does 2x go into negative 10x? Hunter. How many times does 2x go into negative 10x? Close. Close. Remember, it's a negative 10. Negative 5. Negative 5. So up here, I put negative 5. Now, negative 5 times 2x rows. Negative 5 times 2x. Negative 10x. Negative 10x. And negative 5 times negative 3. Giselle? No. Jasmine. Negative 5 times negative 3? Positive or negative? Positive 15. And then what do I do to that? Ryan, what do I do to that? Put what? Parentheses around it. Why? Because I am doing what to it? Ryan. I'm subtracting it, right? Now, Olivia. No, Sophie. Sophie, right? What do I do? Okay, but what is the academic language that I use? I am doing what? The boom, boom, boom is the how, right? But what am I doing? Thank you. Nice and loud. Nice and loud, Sophie. I'm distributing that negative. So this becomes a positive. If I flip that sign, I have to flip the sign of both of these in here, right? So this becomes a positive, and then the 15 becomes a negative. Yes. Boom. That's the last boom. Now I got negative 10x plus 10x. What does that give me, Cora? Good. Good. Did I surprise you there? Good. You did well. Brandon. What? Plus 15 minus 15. 0. I have no remainder. So what that tells me is that this divided by this gets me that. Okay. So, riddle me this, Batman.
Oh, I was waiting for that.
If I take this guy, if I take 2x minus 3, and I times it with x squared plus 2x minus 5, what would I get?
You get 2x cubed plus x squared minus 16.
Why, Brandon?
I don't know, but I remember you talking about that. Because math.
Because math, Caleb, using his academic language. These two guys, the 2x minus 3 and the x squared plus 2x minus 5 are what relationship to this? If I asked you, let me ask that question in a different context. 6 equals 2 times 3, yes?
Yeah.
2 and 3 are whats of 6?
Multiples.
Taylor, using her academic language. Multiples, yes, that's kind of a sticky one, but we were looking for factors. Okay? A multiple of 6 would be 12 and 18 and 24. Those are multiples of 6, right? Because 6 multiplied by 1 is 6. 6 multiplied by 2 is 12. So, Soren, you're on the right track. You just got your language mixed up and backwards, right? So, good. 2 and 3 are factors of 6. So what are the factors of 2x squared plus x squared, 2x cubed plus x squared minus 16x plus 15? What are the factors? Josh? What are the factors of this polynomial right here? So I know I took physics in high school. I was talking for like a minute and a half. And I know it takes not a minute and a half for stuff to fall from this table. Like if I roll this off the table, it doesn't take a minute and a half. It takes like a second and a half. All right. So these two guys are what to this? Factors. Okay? Remember that. It is coming back. I promise you it's coming back. Okay? Factors. Got it. Okay. Now, here's what we're going to do. We're going to do this guy.
No, not the number 2.
Number 2.
Oh, yes.
So we're going to do this on another sheet of paper. So bust out a sheet of paper.
Can I just do the same one?
Yeah. If you got a separate sheet of paper already on which you wrote this one, you can just continue it there, okay? So, write it down. 3x to the 5th plus 12x to the 4th. 3x to the 5th plus 12x to the 4th. 11x cubed, 2x squared. Yes, it is. Minus 4x minus 2. All right. And I'm doing 3x squared minus 1.
And a little car go fast.
All right. Yes? Okay. That is a lot of work. Okay. Now, I ask you, this, what do I want to do with that negative 1? Ignore it for now. Yep. Take it, grab it, put it in your pocket, save it for later. It's right there. Negative 1 is right there. 3x squared times what gets me 3x to the 5th?
Bless you.
X to the 3rd. Do you agree with that, Zach? X to the 3rd. And where do I put it? Put it in my x cubed column, right? Put it in my x cubed column. X cubed. Okay. Now, that negative 1 that I have in my pocket, I'm taking it out of my pocket, put it back up there. Now, I multiply this guy by this whole thing. And I get x cubed times 3x squared gets me what? 3x to the 5th. Okay? X cubed minus 1 times minus 1 gets me what? Negative x cubed. And then what do I do? Draw the line under it, right? And then what do I do? Put the parentheses around it. And then what do I do? Subtract it. And now I distribute the negative. Boom, boom, boom. And 3x to the 5th minus 3x to the 5th gets me 0. 12x to the 4th minus x cubed gets me what? I can't do that, can I? I can't. Well, I can. I can. But here's what I'm going to have you guys do. Okay? You guys are going to hate me. Let's erase this right here. Actually, we're going to erase this right here. Oh, snap.
Nice.
We're going to erase that right here. Okay? And we're going to, and I didn't leave room for myself because I'm not very smart, but I'm going to write this plus 0x minus 1. Why did I write the 0x? Let me ask you this. If I wanted to write 3 hundreds plus 8 tens plus 2 ones, so 3 times 100 plus 8 times 10 plus 2 times 1. If I add all that together, what do I get?
382.
382, very good. Right? 3's in the 100 spot, 8 in the 10 spot, 2 in the 1 spot. All right, now, if I say 3 times 100, 0 times 10, and 2 times 1, what is that?
302.
302. But why don't I write it like this? Why don't I just write it like that? Because that's how I wrote this one originally, right? I got 0 x's. Why even put it in there? It doesn't change the value of this, right? But when I write my number, I need to have it in there, don't I? So I put that 0 in there, even though I know I got 0 tens. This is really when back before the Renaissance, you went to college to learn how to multiply because you did multiplication with Roman numerals before the Renaissance. So, who knows what 302 in Roman numerals is?
No.
No? C, 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 I, I.
How do you know?
Because C stands for what, Camden? 100. I stands for 1, right? Multiply that by MXM, which is 1,900. You had to go to college to learn to do that. Roman numerals did not have a value for 0. There's no such thing as 0 in Roman numerals. 0 came by relatively recently. The Indians, not the American Indians, but the Indians in India, came up with the concept of 0. They passed it on to the people in the Middle East, who passed it on to us via the Silk Road. And in about 1350, a guy by the name of Leonardo of Pisa, also known by the name of Fibonacci, said, we should really use numbers like this and not like this. And they resisted it for like 200 years because they thought these numbers were a ploy by those crazy people out east to try and subvert our civilization. We thought these were the numbers of the devil.
The real numbers? Or 0?
Numbers with 0 in them. Anything other than our Latin Roman numerals were numbers from the devil. So we resisted these for years. But this is what unlocked mathematics for us. Okay? We include it when we divide because we need a placeholder. So now when we multiply this, x cubed times 3x squared is what? 3x to the fifth. 3x, or x cubed times 0x is what, Caleb? 0x. I really don't need to write x to the fourth, but I'm going to, so I can put it in my x to the fourth column. So 0x to the fourth. And then x cubed times -1, Camden? -1x cubed. Very good. -1x cubed. Now, I put the parentheses around it, and I distribute the negative. Boom and boom. And I get -3x to the fifth plus 0x to the fourth plus 1x cubed. Okay? Now, I did this subtraction already, right? This is what? 12x to the fourth. Thank you, Bailey. Plus 12x to the fourth. And then I got 11x cubed plus 1x cubed, which is 12x cubed. And then what do I do, Andrew? What do I do?
I have no idea.
I'm going to bring this guy down. When I do long division, I always bring the next digit down, right? This is the next digit. So plus 2x squared. Right? Now, how many times does 3x squared go into 12x to the fourth?
4.
4x.
2.
Let's use our right term.
Squared.
Thank you. 4x squared. So 4x squared. So 4x squared times 3x squared gets me positive 12x to the fourth. 4x squared times 0x, Soren? 0x, x squared times x's to the third, right? Because I want to put it in my thirds pile, right? Plus 0x cubed plus 4x squared times -1, Rose. What you got for me? 4x. No. I'm not a okay. Did you just do an SMH? 4x squared times -1. Very good, thank you. -4x squared. What do I do now? I draw the line. What do I do next? Parentheses. And then subtract it, and then Caleb's cutting to the quick, I distribute the negative. So if this becomes positive, then this changes signs, this changes signs, that changes signs. And I get 12x to the fourth minus 12x to the fourth, which gives me what, Michaela? 0x to the fourth. 12x cubed minus 0x cubed gets me what, Taylor? Right here, we're in this column. 12x cubed minus 0x cubed. 12x cubed plus 12x cubed. And then 2 plus 4 in the column of x squareds gets me what?
6x squared.
6x squared plus 6x squared. And what do I do this time, Andrew? -4x. Hey. Excellent. Okay. Wash, rinse, repeat, right? We do the same thing again, except this time it's how many times does 3x squared go into 12x cubed? 4x. Positive or negative? Good. And then I multiply that through. Everybody on their own. Multiply 4x times this polynomial. Write it down here and show me what you got. I'm going to have a cup of coffee. ahead of you, right? So we're 2 spots over. So you kept up here, but you didn't write your. Oh, you're doing it up there. Oh, okay. When do we get out in this class?
49.
49? Diddy?
I think 49.
All right.
What?
Really?
Jack.
Yeah, but sometimes you have to be like, you're not really sure. I have to do that. So I'll figure out their way. Why do we have to tell you? You're welcome.
Remainder.
Plug in 4x. So,
Okay, we did it right.
and then just we're gonna find out whatever. Like we did this up here. We're supposed to do all that 4x. So we're gonna do that. Okay.
All right. What did we get? Let's see.
Wait, so
How about, yes, sir.
we put when we multiply 4x squared times 3x squared, you put that under the 12x cubed?
Hold on. We're not multiplying 4x squared. We're multiplying 4x.
I mean 4x. That's 4x.
So you get 12x cubed, right? So what do we put that under? Put it in the cubes pile, right?
Yay.
Cubes go in the cubes pile.
So why do you add the 0 up there?
Same reason I write this as 302 and not 32. Right? I keep track of how many tens I have by writing that number like that, right? I want to keep track of how many x's I have so that, remember when we tried doing this the first time? I had x cubes right here. I was subtracting 12x to the fourth minus 1x cubed. Do you remember that? And we can't do that, can we? So we put this in here so that I get x cubed times 3x squared is right here. X cubed times this gets me this, and I can subtract x to the fourth from x to the fourth. You feel me? So I want to have squared, single, 0 x's. And if it happens here, we're going to do the same thing. Okay? Now, so what did we get? Abby, what'd you get here? The whole thing.
12x cubed plus 0x squared plus 4x. Once we distribute.
It was, yeah, once you distribute, but it's minus 4x right now, right? And then we put the parentheses around it, subtract it, and distribute the negative. Boom, boom. And then I get what? I get 0, 6x squared. And then this, negative 4x plus 4x is 0x. And then I bring down my minus 2. And I ask you, 3x squared times what gets me 6x squared? Name again, I'm sorry. Brooke, what do I get? 2. Positive or negative 2? Positive 2. And then 2 times 3x squared. We're going to go through this quickly because we're running out of time. 6x squared. 2 times 0x gets me 0x. 2 times negative 1 gets me a minus 2. Wow. Parentheses. Subtract these. Distribute these. Ah. And then 6 minus 6. 0 minus 0. And 2 minus, or negative 2 plus 2. I get no remainder. I get no remainder. Now, who remembers getting remainders in long division?
Yeah.
We are going to deal with that. We will cope with that. Once we cross that river, we will build a bridge with which to cross it. For now, For now, here's what I want you guys to do. This is the problem set. In lesson 4, we're going to do numbers 5 and 6. Let me see if that's reasonable given what we talked about today. 5 and 6.
6 is not.
Okay.
Oh, yes, it is. Oh, yes, it is.
Okay.
6 is reasonable.
And problem set?
Yep, in lesson 4 problem set, numbers 5 and 6. Those are what I want you to do. Also,
Yeah.
2,
You can ask us.
where is it? In lesson 4, yeah, do exercise or examples 1, 2, and 3. Oh, let's see an example 3. Oh no, exercises. Exercises 1, 2, and 3, and problem set 5 and 6.
On lesson 4?
Yes, on lesson 4. Yes, sir.
So you got 5 and 6.
I have a lot.
Go!
I think I have 3.5.
Math.
Actually, Trey was here yesterday. Y'all, were you agree with me yesterday, Ty?
Yeah, it's. I think we just didn't see it because we have a
Skull.
I remember.
Wait, it's less than
So the last one, right? I was left with 6x squared. 3x times
2, 3, and then lessons 1 or lessons what? 1 and 5.
Hold on. Did I just mess this up?